All right, my name is Tyler Flores, and I'm an open source developer, mainly in JavaScript, some Java, and C++ and things like that too. And we have Elliot.
Elliot Weber, I'm a self-employed C programmer, low-level Unix system programmer, and expanding my development skills at this point.
Hi, I'm Ben. I'm an electrical and computer engineering master's student, and mostly Node.js, Java, that kind of stuff, but also reaching out about new stuff just because of all the Bitcoin applications.
Before you go to Elasticsearch, do you want to talk about maybe your learnings? Because this is going to be 2 minutes before we start. Learnings about the project.
Okay, yes. So basically our project is, it's called ChainScope. And the idea is to take the Bitcoin blockchain and to load it into the Elasticsearch database and see how flexible that is and what kind of data you can get out of it. So I don't know how many people have used Elasticsearch. Probably heard of it. I don't know who's used it. A few people. Yeah. So for us, that was a lot of what this project was about. Was just learning how to use Elasticsearch itself, in addition to trying to learn Bitcoin at the same time.
Can you tell us what Elasticsearch is?
Yeah, so what it is, it's a database that a lot of people know as a full-text query database, but it actually supports a lot more than that. And so what it is, it's based on Lucene indexes, which was it was an indexing library. So what it lets you do is, instead of a normal index that maps from like an ID to a document, it maps from the contents of the document to the document itself. So you can do a full-text search, so you can do a keyword search, and you can get the document you're looking for. So you can look for like dog or foxes in a blog post, and the document will come up when you search for it. So basically Elasticsearch does that. And so basically we were using it for the Bitcoin blockchain, and I wasn't so sure of it at first, but one of our other partners who isn't here right now, Victor, he had a familiarity with it, and he thought it would work pretty well, so we tried it. And he set up a node, and we set up a few nodes ourselves as well. And it actually works pretty well, and there's some nice things about it, really. So one of the cool things about it is if you look at this comparison to like relational databases, you can see kind of right here, basically what you have equivalently between the two different kinds. So basically, Elasticsearch basically gives you a document database. It's kind of like MongoDB effectively when you're using it. You end up having these JSON documents, and it's schemaless, so you don't have to define it up front, which is really nice. And it has various fields. And so basically, the way that we have it working is we connect, we run this Node.js module that we found called Elastic Blockchain. You can get on NPM. And what it does is it basically links Bitcoin D to Elasticsearch. It just does an endpoint. It does an extraction. So you basically start them both up, you give it the configuration, and it just starts this process of loading all the blocks that you have on Bitcoin D from the JSON RPC into Elasticsearch, and just using those original API commands that you have down here. So yeah, and it resumes sessions, and it just checks for the last block height basically, and it loads the block, and it loads all the transactions for the block and just loads it in. And it's really nice because it detects all the data types automatically, and it automatically indexes them. And so kind of the trade-off there is that it ends up taking up a lot of space, basically. So the Bitcoin blockchain is already like 30 gigabytes. And so the people who made this project, they said it would be about 220 gigabytes when you load the full blockchain. And actually, we don't even have the full thing on a single node, really. I have one node here on a VM, and it has the first 120,000 or 130,000 blocks or so. And that ended up being 1.8 gigabytes, about 2 gigs. And then down here we have another node that has blocks 300,000 through 320,000, and it ended up being 42 gigabytes. So those later blocks are way bigger than the earlier ones because they have a lot more transactions in them, basically. And so one of the future directions really is to basically figure out how to load them all in reliably, because that was one issue we were having was sometimes you get errors or halts or crashes, and you have to resume. That's one thing that we're doing. So I can give you like a short little demo that just kind of demonstrates the queries we're looking at. because we're just learning about this really. So right here, this is the Marvel Sense plugin for Elasticsearch, and it's really nice. It's free for development use, and there's a license for professional use. But basically, it just lets you prototype the queries that you're building. So the very first one we have here is just basically it just gets you the count of the total blocks that you have on your database. So here we have, we only have 24,000 blocks here. So it's not that many, but they're pretty big because these are the later blocks. These are 300,000 going forward. And we just have a few example queries that we're playing with as we're getting familiar with it. And so you can get the min block and the max height that you have. You can get query down here for the difficulty. So these are aggregate queries. So that's one kind of cool thing about Elasticsearch is it has these more complex queries that you can do. So, I mean, these are probably statistics that people have elsewhere, but it gives you a little bit of an idea of what you might be able to do with this. Basically, we're just querying on blocks and transactions because those are the data fields that we have. And down here we have a block size query. And these are all on the GitHub, so you can look up this. It's called a ChainScope demo.txt. You can find it right there. So it gives you the min and average sizes of the blocks. So this one's kind of cool. So this one is showing you that you have a minimum block size of, it looks like 183 bytes, and an average size of 24K, and a max size of close to 1 megabyte, which is about what you should be getting, I think, for these later blocks. And we just have more queries down below. So you can look at the actual data of the block, full data. And this is the block without the transaction information, because it actually has that too. So what we're doing is we're doing an exclude filter on the partial fields that excludes the transaction information. So the transaction data and all the hashes. So one of the cool things you can do with this is a little bit more flexible maybe than some APIs that you might be using. Sometimes when you're looking at an API, you know the data that you want to get and you don't know if it has it. So with this, as long as it has it and you can query it, you can probably build what you need. So this is kind of cool if you want to have like an internal infrastructure or something. You just want to be able to get the data directly. So I think that's the main use case really right now for this. And we're still experimenting with queries and seeing, what more valuable use cases we might be able to get and what you might be able to build on top of it, basically. And the other queries down here are similar, just some range queries, and I can show you probably a transaction example. Yeah, and so it's pretty quick querying. It's pretty fast. Here's an example Coinbase transaction. So this just gives you the very first transaction in the blocks. That's that TX0 here that you have. And then you can see all the inputs and the outputs, basically. And so you see the lock time, transaction ID, the inputs, the version, and you also see the scripts, which is kind of cool. So sometimes when you get transaction data off of an API, sometimes you don't get the scripts. So if you're interested, then you can see them. It also supports dynamic scripting, which we haven't done too much with it yet. We haven't done anything really. But it does let you query in various languages, so it has Groovy and JavaScript and Python and things. And that's an issue for security, basically, because the other thing we learned about Elasticsearch is it's not designed to be public-facing. So you don't want to just open this up and then have anybody querying against it, because they can delete your data, basically, by sending delete requests. And they can also run scripts, and that's been an issue. People have had Bitcoin stolen running Elasticsearch on the same server with a hot wallet. So you don't want to do that. You want to lock it down, basically. And a future direction is there might be ways that we can set up an intermediate interface for public use. So that'd be really interesting. Maybe we can get some of the flexibility of this, but have something that people can use like publicly. So that would be valuable too. And that's mainly what you have. I mean, you can look at the output scripts and the input scripts, and you'll see what you're expecting. I'll show you op returns. The only thing is we're not translating them, so you won't see any ASCII text or anything like that because we haven't done that dynamic scripting yet, really. But that's basically what you have. If you want to learn more about it, it's on the GitHub, and there's a couple things. We have the project notes, which are the presentation notes, We have future directions if this is interesting. If you want to run an interesting query, you can just ask us about it and we'll see if we can do it. I like Andy's idea earlier about building like tools in an ecosystem that like other groups in this class can use and build on top of. I think that's really cool. So if you're interested in learning how to do this, we have the full Ubuntu installation notes that'll show you how to set up your own node. Basically, it walks you through all the steps, everything you need to install, and it shows you how to do everything and how to secure it and how to get Marble Sense and run Bitcoin and get it all connected, basically. And that's about it.
I'm just curious, like, what is your part of the code? Is it actually the filters or importing?
Oh, what's the what?
I'm just wondering, what's the cold part of the project?
The cold part?
Yeah, do you write any code or just manually importing the database?
Oh, the code part.
Can you repeat
Yeah,
the
so
question?
basically
Can you
this
repeat
was-
the question?
Right, so the question is, what was the code part of the project?
Yeah.
And so really it was only these queries. The rest of it was really mainly just infrastructure and setting it up, just using existing modules to see what you could do, what you could build, and and see what makes sense, basically. So that was really it. We were thinking about building like a blockchain explorer on top of it, but we decided early in the week just to focus in on the search aspect and see what we could do, because we're just learning it earlier ourselves. So just decided to focus on that.
Got it.
Yeah.
Do you have the ability to add your custom filters? Wired filters?
Filters?
Custom filters, queries.
Yeah, so that's the really cool thing is you can add any filter that you want, basically. So add a couple down here where it's filtering on partial fields. So if you want to exclude fields, yeah, you can do that. And I think you can even build much more interesting things. Like it's really good for visualizations and like monitoring and things like this. So it has this thing called Kibana, which is another plugin, and I think you can build like really cool like charts and graphs and things. So if you're into that, you can probably do some monitoring definitely with this. Yeah, so it'd be cool to check out. Yeah.
So what was the name? Oh, okay, GitHub.
Oh, was it? Oh, the GitHub?
Yeah.
Oh, yeah. So it's my GitHub. You can go to my one name. It's Tyler.Flores.
I got it written down. I'll
Yeah.
send an email about it.
Tyler.Flores.
Yeah, or the GitHub is Quailiabyte. So kind of hard to spell, but
I got it written
Yeah.
down. So I'll try to-
github.com/Quailiabyte /ChainScope.
We'll collect the GitHubs and we'll distribute them, probably internally on the Google group. Great stuff.
Yeah, and I had a one other little project here to show too that I added, which is this Super Satoshi Bros. And this is a really fun one that you guys might like. I thought people just might enjoy it. So basically, it's just a version of the classic Mario game for the NES, where it takes all the coins out of the original Mario, and it puts in coins representing transactions in the Bitcoin blockchain. So if you run it, it should load up here. I don't know if I can play it very well. But basically, what you'll see is it goes to the chain.so API, and it downloads all the transactions from it. So that's what it's doing right now, is it's trying to preload them. And what it does is it downloads, it takes a random block from the last 10,000 blocks, and it chooses that one and downloads the previous 4. And then what it does is it builds levels going backwards, back towards the Genesis block. And then it lets you play through them basically in reverse. And so what you get is you get like level like 300,000 something, and you can play it, and you'll see all the coins will be like transactions from the game. So it should come up here unless it's crashing or something like this. But yeah, there you go. Yeah, so here's the Coinbase transaction you see at like the beginning of the level, and it's kind of cool. So you can like play it. And I thought you guys just might like it because it's just like a fun thing. Because I was thinking about like, oh, you can do like a block explorer or something, but I thought this is a kind of cool way to like experience the blockchain in a different way, basically, kind of more visual. So yeah, you can play with that. It's also at the GitHub. And yeah, that's it.
That will be our first demo in our Blockchain University playground.
Wait, can you stand in front of the Mario Brothers? Sorry.
Oh, you're
Satoshi
in front of
Brothers?
Mario Brothers?
Yeah, can you put the Satoshi Brothers thing again?
Just like awesome.
That's awesome.
Might need to download the blocks again, probably. It'll need to reload. I'll just leave it up.
We should have you stand in front of it.
It'll probably come down.
Jeff and Yvonne will be up next, and then Rhonda, you'll be on deck, and we'll bring you this. So, any other learnings, Elliot? Any want to comment on
It's
any?
just been a great, continuing great experience, just following along and seeing how unlimited this domain is.
What's been the hardest part?
Just keeping up.
Yeah, I had that problem. Any learning? Any libraries that were interesting?
I would say overall, like the Bitcore is already mentioned. I tried using that, and Chain.so and other ones. They're all working. I would like. I'm so gracious for all these people building these things because I'd be completely lost without these APIs. But yeah, just try those out, and you're gonna have some trouble going along, but just keep working through it.
Yeah, so I guess that's it.
Photo in front of
Wait,
the,
can you stand in front of it?
we got our paparazzi.
Stop right
you
here.
know?
Wait, it's on your faces. Can
Move over because it's on
Yeah,
your
can
face.
you-
Come forward.
yeah, or
Come forward a little bit.
can you go a little bit?
Yeah, forward.
Yeah, perfect.
Turn on the lights.
Smile. That's so cool.
I think we have like two more, and then we'll have our break. So we'll do Jeff, Rhonda, and Hans, and then we'll do the break.
Hi, my name is Jeff Flowers. I'm a professor of chemistry at College of San Mateo.
Hi, my name is Yvonne. I'm a web developer and my company is Siliconian. And so we both had background in science and mine in astronomy. So I'm going to talk a little bit about how our idea for this project came from. So our original idea for the final project is for astronomers to put their discoveries in the blockchain. So say if they find an asteroid, they will put the coordinates and then send it using op return, and then perhaps with a multi-sig confirmed by a professional, and send it onto the network. But for the first module of this course, we're going to have a simplified version of that project.
Well, and I also want to give us a name, so we went with Satoshi Secrets. So we'll see why in a moment, why that's going to be apt. So what we did, again, Yvonne was talking about the original idea was to have a ability to have individuals put up their discoveries on a notarized blockchain that they could then later prove that they had done it, and have a consensus model in which you had astronomers that were trusted to verify and sign off on it. But of course, that was a lot more than we realized when we were doing this, so we started simplifying it to the following, which we'll see in a minute. We learned a lot, and I started the process off by looking at how to use op return and how to get that going, and basically spamming the testnet with my op returns. And initially, we had thought about building into a payment system. Or do you want to? Yeah, okay. I want to talk one more last thing, and then Yvonne will take over the next step. But about the op return and spamming. The idea for the sub-project we're going to show came from those initial inquiries into the testnet. I'd come home later after classes, for example, and I'd see replies. And it got me thinking about, well, how could we reuse this? And let's take a look at Coin Secrets. And so here's just, a block explorer in which, you could see spamming it.
This one is not our project, but it shows all the op return data for the testnet, so you can see we've been spamming.
Yeah, and we'll see in a minute. So I'll let Yvonne take over a little bit more about what all we did.
So our original planning for the project was for someone to submit a text message, and then after they submit that, they will be sent to a payment, and then they will pay for basically an address, and then we will receive payment from that address, and then we will grab the transaction ID and then build that op return transaction ourselves. But then, as we were spamming the testnet with op returns, we found out a lot of properties about the testnet that allow us to simplify the project. So basically, you can send a zero amount transaction with op return on the testnet. So you can, and you also can keep chaining unconfirmed transaction one after another. So that allow us to simplify our app a lot better.
Well, what Yvonne, I think, also is saying is we started probing the testnet about how far we could use it and abuse it and see what it could do or what it could not do. For example, there's a 40 byte limit in the main net that doesn't exist. There are non-standard transactions are permitted. Here's just she started writing down, we have a spreadsheet of all the possibilities that you could do on the testnet that could overcome various limitations, like no miners fee, sending notes, whatever. We're just having a lot of fun playing with it. So with that, I want to talk a little bit about the payment network or the payment structure. I'm very fascinated. I love barcodes. People who know me know I'm fascinated with QR codes in particular now that they're open, and I really like using them. Maybe not great for design, but whatever. I like them, so I thought, hey, how about we even just, if we can do it such that the user submits their whatever, hits submit payment, it would generate the barcode, and their wallet would handle all the computations and broadcast down to the network. That didn't quite work, a little bit more complicated. And I thought, well, okay, I'll hand build these QR codes. They're pretty much all the same anyways, but then there were some issues there. And then Yvonne, of course, is a smart one. I'm just there. I just make up, I just write stuff down, look busy. So she came up with how to actually get it implemented and really put it together. Should we show the idea? Oh, you pick. Which one? This one? CoinFession? All right, here we go. CoinFessions.me. That was the other thing. I think Yvonne and I just came up with little cool taglines. So this was one: secured by Satoshi, Satoshi secure, centers redeemed through Satoshi. Oh yeah, there's a lot. Anyway, so secret safe with Satoshi. The idea again here is you write down your confession, for example, and we can now upload it to the blockchain. So let's see.
Jeff would want to do the demo.
So let's write one up. Your
What's your confession?
Yeah, your secret is safe with the blockchain. Ooh, can't spell it for some reason. So we of course make a confessional here. It's now been put up, and why don't we look at the code real quick? And which one? Oh, here we go. And basically, the idea is it signs it, creates a transaction, sends it out, and broadcasts it.
So that's the new transaction that was just sent after we hit that confess button. So it took that piece of text and then put it in the op return transaction, and this is the new transaction that was
I'm guessing it put the hash in the transaction. What did it do?
So it hex encodes our secret, if you will, and then